Hey, welcome. Have you ever really stopped to think about the incredible engineering inside your own body? The stuff that lets you walk, or write, or just nod your head? Well, today, we're going to get into the unsung heroes of our skeletons, our joints.
All right, let's just start with a puzzle. A puzzle your body solves literally every single second. Think about this. How can your skull be this solid, protective helmet, but at the same time, your shoulder can move in pretty much any direction? It feels like those two things shouldn't exist in the same body, right?
Well, the secret, the answer to that puzzle, is all about joints. Now, the basic definition is super simple. A joint is just where two bones connect. But, and this is a big but, as we're about to find out, simple is probably the last word you'd ever use to describe what's really going on.
So how do we even begin to wrap our heads around all this? Well, anatomists have come up with two main ways to classify joints. First, by their structure, what they're actually made of. And second, by their function, what they're designed to do. And if you can get this two-part system, you've basically got the key to understanding your whole skeleton.
Okay, let's jump into our first category, the fibrous joints. Honestly, you can just think of these as the body's version of superglue or heavy-duty rivets. They are built to last, and their whole purpose is strength, not movement. The most important thing to remember about fibrous joints is that they make a major trade-off. They sacrifice pretty much all movement, but in return, they get incredible stability and protection. Their number one job is just to lock things down tight.
And we see these in three very specific forms. You've got sutures, which are like these intricate seams stitching the plates of your skull together. Then there are gomphoses, which is basically the special joint that cements your teeth into your jaw. And finally, syndesmoses, which are like tough ligaments that hold two parallel bones together, like the two bones in your forearm.
And here's a really cool little tidbit about those sutures in your skull. They're not actually fused together when you're born. This is what allows a baby's head to, change shape a bit to get through the birth canal. They don't fully lock up and become completely solid until you're about 20 years old. All right, moving on. Let's look at how the body solves a totally different kind of problem. What if you need strength, but you also need a little bit of give? This is where cartilaginous joints come in. They are the body's great compromise. A great way to think about these is like the suspension system in your car. Their job is to absorb shock and handle all sorts of pressure, but still allow for a tiny bit of movement. And this makes them absolutely perfect for places to take a beating, like your spine and your pelvis. And there are really two main types here. First, you've got synchondrosis joints. These are actually temporary and don't move at all. They're the growth plates you find in a kid's growing bones. But the second type, symphysis joints, those are the real shock absorbers. They use this super tough stuff called fibrocartilage to allow for a little but really critical bit of movement. The joint that connects the two halves of your pelvis right at the front is a perfect example.
Okay, and now we get to the main event, the synovial joints. These are by far the most common, the most complex, and definitely the most mobile joints in our entire body. These are the joints that give us our amazing range of motion.
So what's their secret? What makes them so special? It's a fluid-filled cavity. It's like this little sealed capsule that's constantly lubricating itself, which lets the bones just glide past each other with almost no friction. It's this amazing design that allows them to be so freely movable. I like to think of the synovial joints as a specialized toolkit. Your body has 6 different types, and it uses this toolkit to build every single kind of movement you can imagine, from a simple bend of your finger to the complex rotation of your shoulder. All right, so let's crack open that toolkit and take a look at the 6 different types. You'll see that each one is a master of its own specific kind of movement.
First up, we have the hinge joint. And it's exactly what it sounds like. It works just like the hinge on a door. Super simple, super strong, just moving back and forth in one direction. Your elbow and your knee, classic hinge joints.
Next, we've got the saddle joint. It gets its name from its really cool shape, where one bone sits on another, kind of like a rider sitting in a saddle. It's this brilliant design that allows for the awesome movement you have at the base of your thumb. Then there are plane joints. These are way simpler, pretty much just 2 flat surfaces that glide over each other. The movement itself is pretty small, but it's absolutely essential for all the complex little adjustments that happen in your wrists and your ankles. Now, the pivot joint is a specialist. It has one job and one job only, rotation. The perfect example is right at the top of your neck. It's the joint that lets you turn your head to say no. Okay, the condyloid joint. You can sort of think of this one as a shallow ball and socket joint.
It gives you a lot of movement in different directions, like when you wave your hand around at the wrist, but because it's not a deep socket, it doesn't allow for full 360-degree rotation.
And last but not least, the star of the show, the ball and socket joint. This is the ultimate multi-tool in the body's kit. It gives you the most freedom of movement out of any joint type, which is exactly why you find it in your shoulder and your hip, the places that need to make those big, sweeping motions.
Okay, whew. We've looked at all the individual pieces. Now let's zoom out and put it all together. Let's look at the grand design of this whole system. When you look at it this way, you can see the one fundamental rule that governs everything. It's all a trade-off. An elegant trade-off, really. The more movement a joint allows, the less stable it is, inherently. It's just the law of physics. You can't have maximum mobility and maximum stability in the exact same spot.
So the big takeaway here is that your body isn't just a random collection of parts. It's a brilliantly designed, optimized system. Every single joint, from your skull to your toes, is the perfect solution for its location, trading exactly the right amount of mobility for stability right where it's needed most. And that really just leaves us with one final thought. The next time you go to pick up a cup of coffee, or you turn your head, or you just take a walk, maybe just take a second to think about this incredible toolkit inside of you. Which one of these amazing little feats of engineering are you going to appreciate most today?